I'm Stefan.
And I'm Taran.
Today we're here to teach you how to use a vital tool in any electrician, electrical engineer, or handyman's toolbox.
Yes, we are here to learn how to use a multimeter.
The multimeter is like the Swiss Army knife of electronic measuring tools. It is able to measure current, voltage, resistance, continuity, which is the connection between 2 points, diodes, and the temperature of a circuit. These are all basic functions of most multimeters sold today.
So you are able to go from one circuit to the another and take all these readings just using one simple tool.
Yes, a multimeter is a great troubleshooting tool. You can measure how much charge is left in your battery 1 second and then check to see if your wires are connected the next, because no one likes getting up to change the channel anymore and everyone needs a working remote.
Most low multimeters all have the same functions, but the quality is key. If you need accurate reading or if your device will be taking a beating on the job site every day. So it is good to think of what your device will be doing before you go out and get one.
Before turning your multimeter on, there are a few key things you need to know first. First is connecting the leads. The black lead is generic and just goes in this generic black port. The second is the red lead. When connecting the red lead to your device, you must first think of the operation or the function you want your device to do, and then put it in the port that coincides. For example, I want to check the current. So I'm going to see this A, it stands for amps, and I'm going to connect my red lead to my amp setting.
Now that the leads are connected, you are able to put your multimeter into the circuit. To ensure complete and constant connection, you may want to attach alligator clips in between the leads on your multimeter and the connection on the circuit.
Alligator clips are also great if you're working alone because the connection remains constant, so you are able to take notes with your multimeter still in the circuit. In order to learn how the multimeter's 4 functions work, we're going to go to our technical experts, Joel and Rusland, to teach us how to actually use this device.
Hi, I'm Joel.
And I am Rusland.
These are our technical experts here to teach you how to use a multimeter.
Well, first of all, my coworker right here, Stefan, was talking about continuity. Well, continuity is the electrical path that can be established between 2 points. That is, if there's an electrical circuit that can be made. So, it is useful for probing a circuit board to know how the components are connected to each other, to see if a component is short-circuited, and we can determine that by the continuity test. So first of all, with our multimeter, we will change the knob to the continuity setting, which is that little setting right there. Next step is to verify that it is in continuity mode. We will take our both leads, the red lead and the red lead, to verify that there's a beeping when we touch them together. As you can tell, there is a beep. So we can definitely that there's a connection has been established. If there isn't a beep by any chances, there are a couple things you might want to check. You're going to want to check your multimeter first if it's on or off. It could be off by any incident. Or you could double check your battery if the battery's dead. Next, you could also double check you might probably have blown a fuse. Alright? But if your multimeter does work and you hear this beeping noise and there is a connection, then just skip what I just said. What we talk about is resistance. You may ask yourself, what is resistance? Well, it's exactly what it sounds like. It's a characteristic that makes the components resist the flow of current. In this case, we will be measuring the resistance of a resistor, which is this little bad boy right here. The resistor is measured or has a value in ohms. Most resistors have a range between 1 ohm and 1 mega ohm, and they often have a 5% tolerance. There's also resistor coding. Do we have time for this, Ruslan?
Pretty done.
Alright then. That's the story for another day. But don't worry folks, if you really wanted to learn about resistors and their coding, you can just wait for a second video, which will be coming out on December 2nd for extra marks. Alright, back to resistance. You may ask yourself, what is resistance testing good for? Well, resistance testing is very useful. If you don't have a continuing tester, you can measure how much current is flowing through. You can check the resistor whose values are not clear. It can also test and characterize sensors. Remember, you can only test resistance when the device you're testing is not powered. Your resistance is non-directional, so it does not matter if you take a red lead or a black lead to measure the resistance. It will measure the exact same thing. Now to show you exactly how it works. First, you want to turn your knob to your resistance setting, ohm setting. So here we go. We'll turn it at 20 ohms. Alright. Here we go. Just so forth. And you should see a resistance of 0.02 ohm. Alright. So we can tell that this resistance has a resistor of 0.02 kilo ohms. And here's another note that you should take aware of. You might as well wait 4 seconds as you do it. Alright. That is how you measure the resistance in a resistor.
What is voltage? Voltage is an abstract term. However, most people refer to voltage as potential energy. As you might know, potential energy is the energy that is being stored and not doing any work. However, potential energy has the potential to become kinetic energy, which is energy in motion. Now there are two types of voltage, AC and DC. DC stands for direct current. It's usually used in portable batteries. AC, however, stands for alternate current, which is used in most common household outlets. So the tools we're going to need for measuring voltage is our multimeter, our power source, which is a cell phone battery, and our leads, black and red. Voltage is to turn on your multimeter. The second step is to properly connect your leads. Your black lead always goes to COM, and your red lead always goes to voltage in ohms, like this. The second thing you want to do is to adjust your range on the selector switch, which is here. You always want to start at the highest possible range to make sure your digital multimeter doesn't blow up. Then, you want to take your black lead and your red lead and connect the black lead to the negative side of the battery and your red lead to the positive, like so. If you don't get a reading, you might want to adjust your range. As you can see, the voltage is around 3.7 to 3.9 volts. And then if you check the battery, it says the actual voltage is 3.7 volts. So we just proved our point. What is current? Current is the flow of electricity. It is measured in amps. In simplest terms, current is how fast electrons travel throughout the circuit. So tools that are needed for calculating the current is our multimeter, our breadboard, a power source, and our clips, alligator clips. To measure resistance, your digital multimeter has to be a part of the circuit. We don't have an actual AC power source, so we're just going to pretend this is our power source. So you connect one side of your power source to your circuit, another part to your ground lead, and your red lead to the opposite end of the circuit. And you might want to switch your red lead to amps and change it to amps, of course. And this should give you the actual current.
Now you are able to use your multimeter.